In this problem, we're going to integrate the following function, which is x cubed times the square root of 36 minus x squared. Now, before I begin, we all have our own methods in like integrating or differentiating. But yeah, in this case, integrating. All right. So if you think that your method is useful, or rather suitable in this problem, then you can just comment down below in this YouTube video if you want to share it, right? Otherwise, you can just listen to my own method that I'll be using for me to solve this problem. So, if I'm going to solve this problem, what will I be using? What I will be using is trigonometric substitution. There are like three cases in using trigonometric substitution. But I will only use one what do you call this one? One I will just use one what's that again? One case. All right? I will just use that one case. So what would that be? If you encounter I let A be the constant, so it could be just a number, and X is just basically a term, it's basically a term, right? Just like this, basically. If you wait, if you encounter any problem that has like this a squared minus x squared, if you encounter this type of problem, whether if it's within the square root or there's no square root at all, then you will use this one, your x as a times sine theta. You will use this one, right? So in this case, we have x cubed and square root of 36 minus x squared. Here, we can relate it to this pattern or form. So with that, we can use x as a times sine theta. All right? Now, here's the question. What is your a and what is your x? So I think I've already mentioned this uh, earlier that your a is the constant. Okay? So this one, 36, that is your a squared. So you square root both sides, your a is 6. Okay? So now what we can do is we will substitute it here. So we have x is equal to 6 times sine theta. All right? So that's it. Now, after we substitute 6 as our a and having x as 6 sine theta, what we will do is we will get the derivative of your x. So what is the derivative of 6 sine theta? So recall that the derivative, okay, the derivative of cosine x, no. The derivative of sine x is cosine x, all right? It's cosine x. Therefore, the derivative of sine theta is cosine theta. Then don't forget to put d theta, all right? What variable used here, all right? That will be used here as partner of your d. So sine theta, differentiate it, cosine theta, d theta. Okay? So now, what you will be doing is you will substitute x here and your dx here. Right? So, x, remember that your x is what? 6 times sine theta, right? So, 6 times sine theta cube times the square root of 36 minus your x squared. So, the square of 6 sine theta. Alright? Wait. Is it visible? Okay. Alright. Then times dx. Your dx is 6 times cosine theta d theta. So let me just put it here. Right. Let me just shrink the size of my writing because it will be blocked by my camera here. So yes, 6 times cosine theta d theta. So now we expand. So the cube of 36 6 sine theta is 6 times 6, 36 times 6. Wait, just making sure. 6 times 6 times 6. So that would be 216. So 216 times sine cube of theta times the square root of, here we will have 36 minus 36 sine squared theta times 6, hold on, all right, times cosine theta d theta. All right. So before we proceed to simplify more, let me simplify the problem by bringing out 216 and 6 outside. We can do that. That's actually according to the constant multiple rule of integration, where if you have a constant beside with a function, you can just bring it out. All right. So we can bring out 216 and 6 together. And we can multiply them together. So 216 times 6 will give you 1,296. So 1,296. Right? So what's left is you have sine cube of theta times the square root of 36 minus 36 sine cube of theta. Squared, sorry. Or is it cube? Squared. All right, of theta. Okay, now we can simplify this radical expression rather because it has more than more than one term inside of a square root. We can simplify this one. You see, 36 and negative 36 sine squared theta are both divisible by 36. So we can actually factor out 36 here. So what's left is you have, oh wait, I forgot to put cosine theta here, by the way. Wait, for a while. I forgot to put cosine theta d theta. So let's go. So this would be square root of 36 times quantity 1 minus sine squared theta. Alright? Times cosine theta d theta. So here, we can actually remove 36 outside. Alright? Recall that in I think that's one of the laws of radical or laws of exponent, that for example you have square root of m times n. We can just have square root of m times square root of n. We can do that actually. So with that, since we have 36 and quantity 1 minus sine squared theta as factors, we can separate them. So the result, oh wait, whoa, hold on. So the result, that would be sine cube of theta, I forgot to put theta, times the square root of, oh wait, no, hold on, times the square root of 36 times the square root of 1 minus sine squared theta times cosine theta. Alright? Then 36, square root of 36 will give you exactly 6. Right? This is 6. And since 6 is a constant term, we can just actually bring it out and we can combine it with 1,296. So as a result, oh wait, let me just put it here. So as a result, if you're going to put 6 outside and combine it with 1,296, this will give you 7,776. Okay, there we go. So what's left is you have sine cube of theta times the integral of 1 minus sine squared theta times cosine theta d theta. Now, we can simplify this one, 1 minus sine squared theta. This is actually according to one of the Pythagorean identities in trigonometry, that the sum of the square of sine plus, oh wait, sorry, the sum of the square of sine and cosine, wait, that sounds wrong, wait. Basically, sine squared theta plus cosine squared theta is equal to 1. So imagine that I will transpose sine squared theta on the right. We have cosine squared theta is equal to 1 minus sine squared theta. So basically, we can rewrite 1 minus sine squared theta as cosine squared theta. So that means we will have the integral of sine cubed theta times the square root of cosine squared theta. That's it. Now, if you're going to take a look, we have a square root of a squared function, right? So if you have a square root of a squared function, we can just simply cancel out the square roots. So what's left is this. Okay, we have sine cube of theta times cosine theta times cosine theta. We can combine cosine theta together by multiplying. As a result, you will have cosine squared theta. Good to go. All right, that's it. And that is our simplified answer for our given integral. So what are we going to do? We will now integrate. So here in this given problem, what I will do here is that I will reduce this sine cube theta into two factor, where one is reduced by an exponent of 2. All right. So basically, I can rewrite this as sine cube of theta as sine squared theta times sine theta times cosine squared theta. All right. Next, I will change sine squared theta into something else, which is derived from this identity. All right. So if I will transpose cosine squared theta from the right, I will be having sine squared theta as 1 minus cosine squared theta. Therefore, I can rewrite sine squared theta as 1 minus cosine squared theta. Then, yeah, let's copy the other functions. There we go. Now here, what I will be doing is I will now use u substitution. Okay, I will use u substitution. So here, I will let u as cosine theta. Getting the derivative of your u will give you negative sine theta d theta. Remember that the derivative of cosine is negative sine. Okay? The derivative of cosine is negative sine. Hence, you have negative sine theta as your answer. And don't forget to put d theta. Then, find your d theta here. Okay, let's find d theta. So we will just divide both sides by negative sine theta. As a result, you will have negative 1 all over sine theta du. So you will substitute it here. Okay? So you will have the integral of 1 minus u squared times sine theta times u squared times 1 all over sine theta du. Okay? So now we can simply cancel. Oh wait, by the way, this is negative. I forgot. So for yeah, we can simply cancel sine theta, and then this negative one we can just simply put it out since it's a constant. Since it's a constant term, and if we put it out and we combine it with 7,776, we will have negative 7,776 times the integral of quantity 1 minus u squared times u squared. Whoa, wait, sorry. This is wrong. There we go. Then we distribute u squared to this parenthesis. So as a result, we will have u squared minus u raised to 4 du. And we will integrate these two terms. We will integrate with the application of power rule of integration. So if you have x raised to n, or a variable that has an exponent, then what we will have here is you will have x raised to n plus 1 all over n plus 1 plus c. All right? So we will apply this rule to these two terms because these two terms have an exponent. So hence we will have the So hence the answer here we will have what's that? we will have u raised to 2 plus 1 all over 2 plus 1 minus u raised to 4 plus 1 all over 4 plus 1. Then don't forget to put plus c. So this would be our answer when we simplify it. We will have u cubed all over 3 minus u raised to 5 all over 5 plus c. Okay, but we're not done yet. We're not done yet. Why? First and foremost, we can actually combine, multi distribute this one to the parentheses here. So we will have negative this one, negative 7,776, okay, all over 3 times u cube minus, this would be positive 7,776 all over 5 u raised to 5 plus c. All right. Then the u, it's your cosine theta, right? So we can simply rewrite this as cosine cube of theta plus 7,776 all over 5 times cosine of fifth theta plus c. But we're not done yet actually, because if you're going to take a look on the very first problem, your answer are with respect to x, right? I mean, the given integration here is with respect to x. And the independent variable here, they are all, again, with respect to x. So meaning, we must change this theta or trigo into x. By how? So here we will apply we will apply what we learned in a right triangle. So we have a right triangle here. And suppose this is our given acute angle. Remember that in a right triangle, we have three parts. The hypotenuse, two parts, the hypotenuse and the legs. These two parts, the base and the height, these are like your legs. However, these legs, they have their own specific parts, you know. This part, this side here, is what you call adjacent. Why is it called adjacent? Because it is adjacent to the angle, or in other words, it's beside with the angle. So therefore, this is adjacent. Now this side here, the height of the triangle, this is not adjacent. All right, this is rather opposite. Why is it called opposite? Because it's not adjacent to the given angle here. So we will have O. Right, so what's next? Okay, we have this right triangle, so what now? Let's go back to the trigonometric substitution. We let x as 6 times sine theta. Am I right? Right, we let x as 6 times sine theta. So let's rewrite that. X is equal to 6 times sine theta. Now let's find sine theta. So to find sine theta, I will divide both sides by 6. So I have x all over 6 is equal to sine theta. Now let's recall at least 3 trigonometric ratios, okay? Let's recall those 3. So remember that sine theta is equal to the ratio of opposite and hypotenuse, or in other words, O all over H. Cosine theta, on the other hand, it's adjacent all over hypotenuse, and tangent is opposite all over adjacent. That's it. Okay? So, now, we will take a look at sine theta. Sine theta is again opposite all over hypotenuse. So that means whatever's above on the fraction, that's your opposite, and what's below on the fraction, that is your hypotenuse. Therefore, your x, since it's above or it's in the numerator, that's your opposite. And your 6, that is your hypotenuse. Okay? So you have 6 as your hypotenuse and your O as x. Now, how about for your adjacent? We need to find that adjacent. So here you will use Pythagorean theorem to find that adjacent side. Alright? So we will have a squared plus O squared is equal to the square of your hypotenuse. We're looking for the adjacent side here. Then here we have the opposite, which is, I do believe it's x, right? So it's x squared. Your hypotenuse is 6, right? So we have 6 squared. So let's find your A. So just transpose x squared to the right. You will have, oh wait, oh that's too fast. So you will have 6 squared, 36, minus x squared, just simply x squared. Then square root both sides to find your adjacent. Your A is equal to the square root of 36 minus x squared. And that is your adjacent. Okay? Now, okay, we found our adjacent, we found our opposite and hypotenuse. So what of it? Like, what are we going to gain if we have this stuff right here? Like, okay, we find cosine tangent. Okay, so I mean, yeah, we find the opposite adjacent hypotenuse. So what of it then? Okay, let me just erase the writing here. What we found here, we will relate it here. Okay? So remember that cosine theta is adjacent all over hypotenuse, right? So we can change cosine theta into adjacent all over hypotenuse. Now, what is your adjacent? What is your hypotenuse? Your adjacent is square root of 36 minus x squared. Okay? All over your adjacent, that is your 6. So we will convert this cosine theta as this. Hence, we will have negative 7,776 all over 3 times. Since this is in cube, so this is has an exponent of 3. So here we will have once again the square root of 36 minus x squared. Wait, sorry. So 36 minus x squared all over 6 cube plus, let me put down the other terms here, plus 776 all over 5 times the fifth power of square root of 36 minus x squared all over 6 n plus c. We can simplify this one actually, right? We can do that. I know it's long, but in the long run, it's worth it. Okay, let's simplify this one. We do not need to change this in the square root. We can just put a parenthesis. We can just simply uh put the exponent of 3 outside from the outside from the square root. So we can just put cube root of 36 minus x squared. Okay? But here we need to cube your 6. So if I remember correctly, it's 192, right? 6 times 6 times 6. Ah, it's 216, forgive me. So the cube of 6 is 216, right? Plus, now we will do the same thing on the other side. All right. So for the square root, just put the exponent of 5 there. So you will have the fifth root of the square root of 36 minus x squared to the fifth power all over 6 to the fifth power, which is 7,776. Right? 7,776 plus c. Then let's simplify. All right. Let's simplify the problem. We can simplify these two numbers here, 7776 and 216, because 776 and 216, they're actually both divisible by 36, you know. So 776 divided by 36, that's 216. So minus 216 all over 3 times the 36 minus square root of 36 minus x squared to the cube to the third power all over 216 divided by 36 will give you 6. Let me take a look. Wait. Okay. 206 divided by 36. Wait, oh, 7. Okay, sure. There's no problem. But we can still simplify 216 by 6, because 206 divided by 6 is exactly 36, So 200, 216 divided by 6, this is 36, and 6 divided by 6 is 1. So as a result, you will have this. You will have 36 all over 3 times the cube of the square root of 36 minus x squared, right? And 36 divided by 3 is actually 12. 12. So the answer here is negative 12. That's the answer. All right? Now, how about here? So here, this one is actually easy because all we need to do is just cancel out 7776 on both sides. All right? So what's left is we will have 1 all over 5 times the square root of 36 minus x squared to the fifth power. Let's see. And that is our answer. All right? That is our answer. We've come a long way actually. Wait, just to be sure. I don't want to make mistakes. All right? Just want to be sure in terms of simplifying. 776 3 times what's that again, right? 6 wait, 6 to the cube, right? 6 cube. Oh yeah, correct. It's 12. And that one we have this raised to 5 square root. Okay, yeah. We can leave this as our final answer. All right?